They've digitized themselves, placed their consciousness on a laser beam, and there's a laser highway that could be right next to Earth for all we know, carrying the digitized souls of civilizations, and we're totally clueless. We're so stupid we don't even know that that's how the aliens move from place to place. A breakthrough in quantum computing might be the key to unlocking the mysteries of exoplanets. Scientists have just used the Majorana 1000 Qubit chip to analyze Proxima B, and according to some experts, this could change everything we thought we knew about distant worlds. Proxima B is the closest known exoplanet to Earth, yet much about it remains a mystery. Could it support life? Does it have an atmosphere? For years, astronomers have struggled to find clear answers. Now, with quantum computing pushing the boundaries of what's possible, NASA scientists and AI experts are using cutting-edge simulations to reveal details that were once impossible to detect. Michio Kaku, a leading theoretical physicist, has long argued that quantum computing could revolutionize space exploration. Quantum computing has the potential to unlock the deepest secrets of the universe, he says. If applied to exoplanet research, we could be looking at the future of space exploration. For the first time, one of the most advanced quantum chips ever built has been tasked with analyzing Proxima B. What it just uncovered is already raising serious questions. Why Proxima B matters. Proxima B has fascinated scientists ever since its discovery. At just 4.2 light-years away, it is the closest known exoplanet to Earth, orbiting within the habitable zone of its star, Proxima Centauri. This means that, under the right conditions, liquid water could exist on its surface, a key ingredient for life as we know it. But despite being our cosmic neighbor, Proxima B remains a mystery. Its parent star is a red dwarf, known for extreme solar flares that could strip away atmospheres and make the surface inhospitable. Some studies suggest the planet might be tidally locked, with one side facing perpetual daylight and the other trapped in darkness. Others propose that it could have a thick atmosphere or even a vast ocean beneath a layer of clouds. The debate has continued for years. Could Proxima B be the nearest world capable of supporting life, or is it just another barren rock? The Majorana 1000 Qubit chip. This is where the Majorana 1000 Qubit chip comes in. Traditional computers struggle to model complex planetary environments, especially when faced with the sheer number of unknowns involved in exoplanetary conditions. Classical simulations require enormous computing power, but even then, the results are often incomplete or heavily reliant on assumptions. Quantum computing changes the game entirely. The Majorana 1000 Qubit chip, one of the most advanced quantum processors ever built, was designed for extreme calculations. Instead of analyzing planetary data linearly like traditional computers, it can process countless variables simultaneously, providing a far more accurate and dynamic simulation of Proxima B's climate, atmosphere, and potential for habitability. If quantum computing can successfully simulate the complex physics of an exoplanet, it could change how we search for life in the universe. But what happened when scientists used this technology to analyze Proxima B? The results were unlike anything they expected. How Majorana analyzed Proxima B. To unlock the secrets of Proxima B, scientists turned to the Majorana 1000 Qubit chip, one of the most advanced quantum processors ever built. Unlike traditional supercomputers, which rely on brute force calculations to simulate planetary conditions, this quantum chip can process vast amounts of data simultaneously, revealing patterns and anomalies that would otherwise remain hidden. Researchers fed the chip decades worth of observational data collected from space telescopes, including high-resolution spectroscopic measurements and infrared scans. These datasets contain crucial information about Proxima B's atmosphere, its interaction with stellar radiation, and the way light behaves as it passes through its environment. Using quantum algorithms, the chip reconstructed an ultra-detailed model of Proxima B's atmospheric composition. It mapped temperature variations across the planet's surface, analyzed how its atmosphere absorbed and reflected light, and simulated possible climate cycles based on the planet's orbital dynamics. This level of precision was previously impossible. Classical simulations took years to process incomplete snapshots, while the quantum chip produced results in mere hours. Then, the quantum chip detected something never seen before in any past analysis of Proxima B. What did the chip reveal? As the Majorana 1000 qubit chip processed the vast dataset of Proxima B, it uncovered something no previous analysis had ever detected. Scientists expected to find a static, barren environment, perhaps a thin atmosphere at best, or signs of a planet locked in eternal day and night. But instead, the chip identified unexpected fluctuations in the atmosphere, patterns that defied prior models. These variations weren't random. They followed a cycle, something resembling seasonal shifts, a phenomenon typically observed on planets with complex weather systems. The fluctuations in temperature and atmospheric density suggested Proxima B's climate might be far more dynamic than previously assumed. If true, this could mean the planet has an active atmosphere, capable of distributing heat and energy rather than being frozen on one side and scorched on the other. The real bombshell. Within the atmospheric data, the chip detected molecular signatures consistent with water vapor, a potential indicator of cloud formation, rain cycles, or even an ocean hidden beneath a dense layer of gases. Even more intriguing, faint traces of organic compounds appeared in the spectral analysis. These carbon-based molecules are the building blocks of life as we know it. The implications were staggering. If Proxima B's atmosphere is shifting over time, it could mean that its climate isn't static, but evolving. Could it have a weather system? A hydrological cycle? The presence of organic compounds raised an even bigger question: could these fluctuations hint at biological activity? If these signals are what some scientists think they are, Proxima B might not be a barren world after all. Could this mean Proxima B is habitable? The discovery of atmospheric fluctuations, possible seasonal cycles, and molecular signatures of water and organic compounds has left scientists with a profound question. Could Proxima B be habitable? While it's too early to draw definitive conclusions, researchers have proposed three possible explanations for the anomalies detected by the Majorana 1000 qubit chip. Stars emit intense bursts of radiation, which could be causing extreme yet periodic atmospheric shifts. If the planet's atmosphere is constantly being reshaped by Proxima Centauri's stellar activity, it might explain the irregular climate patterns detected. However, this scenario would likely make habitability difficult, as extreme solar flares could strip away any protective atmosphere over time. A second, more tantalizing theory suggests that Proxima B may have an ocean or subsurface water beneath a thick atmosphere. If confirmed, this would make it one of the most promising exoplanets ever discovered for the search for extraterrestrial life. Liquid water is the foundation of biological processes on Earth, and if it exists on Proxima B, it raises the possibility of microbial ecosystems developing in its depths, much like the hidden oceans beneath the icy crusts of Europa and Enceladus. But the third explanation is the most controversial. Some researchers have pointed out that the fluctuations detected by the quantum chip appear to be structured and highly specific rather than random. This has led to speculation that the anomalies could be the result of an unknown planetary process, or something artificial. Could these signals be a byproduct of geological activity, a form of complex climate regulation, or even something engineered? While this idea remains purely speculative, it has fueled discussions about the potential for non-natural influences on exoplanets. What makes this discovery truly groundbreaking is how it challenges previous assumptions about Proxima B. Earlier studies suggested the planet was tidally locked, meaning one hemisphere was in permanent daylight while the other remained in eternal darkness. This scenario made it unlikely that the planet could sustain a stable atmosphere. However, the new data from the quantum chip indicates that Proxima B may experience atmospheric shifts or even planetary rotation, altering how we perceive its climate and potential habitability. And here's the craziest part: scientists now believe we can test these findings, and the answer might be coming sooner than we think. The discovery of atmospheric fluctuations, possible seasonal cycles, and molecular traces of water and organic compounds on Proxima B has sparked excitement among scientists. But speculation alone isn't enough. These findings need to be confirmed through independent methods. The question now is, can we prove what the Majorana 1000 qubit chip detected? One of the most powerful tools at our disposal is the James Webb Space Telescope. Equipped with cutting-edge infrared spectrometers, Webb is already scanning distant exoplanets, analyzing their atmospheres by studying how starlight filters through them. If Proxima B does have a stable atmosphere with water vapor or carbon-based molecules, Webb will be able to detect the chemical signatures with unprecedented precision. Beyond Webb, scientists are preparing for the next generation of observational powerhouses like the Extremely Large Telescope, ELT, set to become operational in the next few years. With its massive 39-meter mirror, the ELT will be able to directly observe exoplanets and search for biosignatures, key indicators of potential life. If Proxima B harbors an ocean, active weather cycles, or even traces of biological activity, these telescopes could confirm what the quantum chip has suggested. But direct observation isn't the only path to verification. Researchers are also working to replicate the Majorana chip's findings using different quantum computing systems. If other quantum processors running independent models detect the same fluctuations and molecular patterns, it will strengthen the case that these anomalies are real and not just artifacts of a single computation. If Proxima B turns out to be the only exoplanet exhibiting this type of structured atmospheric variation, it raises an even bigger question: why? Is this planet truly unique in some way, or are we on the verge of discovering an entirely new class of habitable worlds? But if this isn't just a mistake, what does it mean for the search for alien life? The Majorana 1000 qubit chip has just helped scientists uncover one of the most intriguing planetary mysteries of our time. For years, Proxima B was considered little more than a distant, possibly lifeless world. But now, thanks to quantum computing, we have evidence suggesting something far more complex: a planet with shifting atmospheric patterns, potential water vapor, and even traces of organic molecules. If these findings hold up, Proxima B could be the closest habitable world outside our solar system. A planet that once seemed unremarkable may now be a prime candidate in the search for extraterrestrial life. And this is only the beginning. With tools like the James Webb Space Telescope and next-generation observatories like the Extremely Large Telescope, we're on the verge of answering questions that have remained unsolved for decades. Michio Kaku and other leading experts have long believed that quantum computing will redefine how we explore space. If a single breakthrough chip can unravel secrets about an exoplanet over 4 light-years away, what happens when even more powerful quantum systems come online? How many other planets once dismissed as barren might be hiding something extraordinary? If quantum AI is already making discoveries like this, what happens when the next generation of quantum chips comes online? Do you think Proxima B could actually be habitable? Drop your thoughts in the comments before we reveal what scientists are saying. If you found this discovery fascinating, you won't want to miss what's coming next. Subscribe and turn on notifications so you're always the first to know.